Hi everybody. So what should these symbols mean? A sub n goes to infinity. What about a sub n goes to negative infinity? Okay, so the idea, we're trying to capture the intuition. What intuition? The a sub n get as big as you like. They get as big as you like. Let's ignore the negative infinity for now. We'll first do a sub n goes to infinity. They get as big as you like, and they stay that big. They don't jump around. And stay there. And stay bigger. And stay even bigger. After. Okay, so that's the intuition. Now here it is we say a sub n goes to infinity if for any big, capital B for big, I don't know, you can call this whatever you want, for any big positive number, there exists a capital N, an index, such that for all the indices past that capital N, we have. And now you see that the difficulty is we can't really do this, less than D. Well, because before we would say for any we were thinking any very small positive number, then the difference between a sub n and infinity should be that small. But this is a problem. We don't know how to do a sub n minus infinity, and so this sort of won't work. This won't work. So instead, we say that a sub n goes to infinity if for all numbers, I'm going to call it capital B, but you see it's still just a positive number, so I could have called it little d. There exists an index such that going past that index implies we have, what do we have? The a sub n's are bigger than b. So as big as you like, it has to hold for all b. This means for all positive numbers. The a sub n's will be that big and even bigger, and they will stay that big. Okay, so for all b, there is a cutoff that if you go past that cutoff, the a sub n's are that big and even bigger. That's the idea. This is sort of a precise definition. Okay. Great. And so this is how we sort of escape the problem of we can't do a sub n minus infinity less than d, which would be, converging to infinity. This doesn't really make sense, but this does make sense. Okay. Now, what about negative infinity? So for all capital B a positive, if I make it a positive number, if it's a positive number, there exists an index such that going past that index implies that the a sub n's are, well, now here's the problem. This would make it positive. So why don't we just say that the a sub n's are smaller than minus b? That would work. Here's one possible answer. Now, of course, if you don't like this minus b for a b positive, then you could say for all b that are negative, that are strictly negative, there exists an n such that going past that n implies that a sub n is less than b. That would be, these are equivalent. They're two different definitions that turn out to give the exact same results. Okay. Oh, and then I'm actually realizing here that I made a mistake. The mistake I made is I put absolute value there. This would, so if I chose, what about this sequence? -1, minus 2, minus 3, minus 4, minus 5, minus 6, forever. You see that this sequence here, if the a sub n is equal to minus n, that would fulfill this definition. So because when I put it into the absolute value sign, the minus would become a plus, and I could make this for any big number. I could find a cutoff for this particular sequence, and we don't want to say that this goes to infinity. We'd like it to go to negative infinity, if anything, and so this is a bad definition. So how can I fix this? A sub n greater than b. Okay. Now this works. Now we have that this is true, that it doesn't go to infinity, because the minus signs won't become positive, because I did not put absolute value. Okay. And that actually shows one more thing that I'll put as a comment. These definitions only make sense when the a sub n are real numbers. Definitions, they don't make sense, don't really make sense for complex numbers. Well, it's not that they don't make sense for complex numbers, because we don't have the greater than sign. You cannot say that z is greater than w for two complex numbers. If this is z and this is w, which one is greater? There is no greater than, there is no less than. We could say that the size of z and the size of w have a greater than or less than relationship. That's okay, because the size made it into a real number. The size made it into a real number. And so this is sort of interesting that these symbols really only make sense for real numbers. Why? Because in the definition, we needed to say greater than or less than, and that doesn't make sense for complex numbers.